Hello everyone, this is Pavani, Assistant Professor in IT Department at XMIT. Now we are going to look into Database Management System. Subject 4 will be CC is 3492. Moving on to course outcome 3. Construct queries to handle transaction processing and maintain consistency of the database. Third unit will be transaction. Let us continue with this. Deferred update. Okay. Deferred update is a recovery technique used in database management system to maintain data consistency during transaction. It updates applied after commit, log records maintained first, okay, and then no changes before commit, and then redo required after crash, no undo needed, ensures atomicity, simple recovery method, and safe execution. In deferred update, or also called no undo redo technique. Okay. All updates made by transaction are not immediately written to the database. Changes are first recorded in the log file. Actual database updated only after transaction commit. It is also called the deferred database modification technique. Let I tell you how it works. First thing, transaction will start. Second, all write operations are stored in the log. Third, database is not modified immediately. Fourth, if the transaction commits, the changes are applied to the database. Then fifth, if the transaction fails before commit, no changes are applied. So no undo is required. Okay. And then recovery rule for this deferred update. If a crash occurs, redo committed transactions. No need to undo uncommitted transaction, okay? Since database was never updated. Advantages of using deferred update is simple recovery, no undo operations required, maintain database consistency. Disadvantages will be updates are delayed, not suitable for very large transaction, require sufficient log storage. Moving on to immediate update. Immediate update is a database recovery technique where changes made by a transaction are returned to the database before the transaction commits. It is also called the undo and redo technique. Let me define you simply. Database is updated immediately after each write operation. Changes are recorded in the log file before writing to the database. Actually, write ahead, logging. Okay. If crash occurs, both undo and redo operation may be required. See, its updates applied before commit, both undo and redo needed, log stores old and new values used in practical systems. Faster execution will be performed. It requires careful logging. It ensures durability, more complex recovery. Let us tell you how it's work in immediate update. First thing, transaction start. Second, before updating the database, system writes a log record. Third, database is updated immediately. If the transaction commits, changes are permanent. If the transaction fails, changes must be undone. Okay. And then see, recovery rule for this immediate update is after crash, redo all committed transaction, undo all uncommitted transaction. Okay. Advantages of using immediate update will be faster updates, suitable for large databases. It also better performance for long transactions. Okay. Moving on to snapshot isolation. It is a concurrency control mechanism used in database system to avoid conflicts between transactions while maintaining consistency. Okay. Under snapshot isolation, each transaction works on a snapshot, like copy. Snapshot means copy of database taken at the time the transaction started. And then basic idea will be nothing but when transactions start, it sees a consistent snapshot of the database. It does not see changes made by each concurrent transaction. Updates are applied only if no write conflicts occurs. Okay. Transaction see consistent snapshot, reads from committed data only, prevents dirty reads, use multi-version approach, avoids read-write conflicts, improves performance, common in distributed systems, maintains isolation. Let us see how it's work. First, transaction T1 starts. It creates the system, a snapshot of the database. After that, T1 reads data from the snapshot. Again, after, if another transaction T2 modifies data, T1 does not see those changes. When T1 tries to commit, if no other transaction modifies the same data, commit is allowed. If write conflicts exist, transaction will be aborted. Okay. It doesn't allow dated reads, non-repeatable reads, no read locks required. Readers do not block writers. Okay. Example C. Assume that A equal to 100. T1 transaction 1 starts, sees A equal to 100. T2 updates A equal to 200 and comments. T1 still sees A equal to 100 in snapshot. If T1 tries to update A conflict, T1 aborts. Okay. Moving on to multiple granularity locking. Multiple granularity locking is a concurrency control mechanism that allows transaction to lock data at different levels of the database. Instead of locking only individual rows, the system can lock entire database, table, page, and then rows. This improves performance and flexibility. Why we need multiple granularity locking is, if we lock only rows means we need too many locks. Overhead increases. Entire table need to be locked means reduce concurrency. So this multi-granularity locking provides a hierarchical locking structure. Okay. Lock hierarchy will be database to table, table to page, and then page to row. Locks are applied from top to bottom in this hierarchy. Actually, multi-granularity locking locks at different levels, database, table, pages, row levels, uses intention locks, improves efficiency, reduce locking overhead, allows flexible control, prevents conflict properly, used in hierarchical database. Moving on to shadow paging. Shadow paging is a database recovery technique that avoids using a log file. It ensures atomicity and durability by maintaining two versions of page tables: current page table, shadow page table. See, it maintains shadow copy of database, updates on new copy, original remains unchanged, commits replaces pointer, no undo is required, simple recovery, high overhead used in some system. Check how it works. Transaction begins. Shadow page table is kept unchanged. When a page is modified, new copy of the page is created. Current page table points to the new page. On commit means the system updates the master pointer to the new page table. On crash, if commit not completed, system uses shadow page table. Advantages of using shadow paging is no log required, no undo and redo needed, simple recovery process, fast cache recovery. Okay. Disadvantages will be extra storage is required, page fragmentation, poor performance for large database, difficult to handle concurrent transaction. Okay, and then moving on to ARIS algorithm overview. It stands for recovery method, uses write ahead logging, perform analysis phase, redo phase, and then undo phases. Efficient recovery mechanism used in modern DBMS ensures high reliability. Moving on to ARIS analysis phase. This stands for Algorithm for Recovery and Isolation Exploiting Semantics. It identifies dirty pages. It is recovery algorithm used in modern database system like IBM DB2. Okay. Finds active transaction. Recovery has three phases after a crash is analysis, redo, undo. Analysis phase is the first step in ARIES recovery. Its purpose is to determine which transactions were active at the time of crash, which transactions committed, when to start the redo phase. Okay. The steps in analysis phases start from the last checkpoint, reconstruct transaction table, reconstruct dirty page table, determine redo starting point. It builds the transaction table, builds the 30 page table, determines recovery start point, prepares redo phase, uses log records, ensures correct restart. Output of this analysis phase will be transaction table, dirty page table, starting LSN for redo. Actually, why this ARIS analysis phase is important, because without analysis, system won't know which transaction to undo. Same system won't know which pages need to redo. Recovery would be inefficient. Okay. See, suppose at the time of crash, transaction 1 is committed, transaction 2 is active, transaction 3 is aborted. Okay. Moving on to ARIES redo phase. Repeating history from log, reapplies committed updates, ensures database consistency, uses LSN numbers, restores last data, start from checkpoint, improves efficiency, ensures durability. Same in undo phase, it's uncommitted transaction, transfers his log backward, writes compensation log records, restore previous values, ensures atomicity, completes recovery process, guarantees correctness, database becomes consistent. Checkpointing, it saves system state, reduces recovery time, writes dirty pages to disk, records active transaction, minimizes redo operations, improves performance used in ARIES, essential for recovery. Thank you.